That's right, we're talking about gravity today. What does it do? Keeps us all together, you know? Keeps you where you should be, right down on this earth. But like, why does gravity happen though? Today, we're trying our best to understand that. Space-time's kind of just a buzzword at this point that people mostly use when they're talking about time travel in science fiction.
The encounter could create a time paradox, the results of which could cause a chain reaction that would unravel the very fabric of the space-time continuum and destroy the entire universe.
Well, that's exactly how I'm going to be using it today. So the general idea of it can be conveyed on this two-dimensional grid that has dips in it whenever there's a mass placed on it. Whenever space-time bends, not only does gravity happen, but time seems to get a little wacky where it slows down the closer you are to a mass. However, I do have to say this 2D representation is inherently flawed. Space-time acts in a four-dimensional plane. This here is an example of space-time represented on a 3D grid. Magnificent. Large objects such as the sun and Earth warp space-time. Everything bends the four-dimensional space-time grid. This sort of bend redirects objects within it, creating the effect of gravity. The time dilation occurs because of something that Einstein said about theory of relativity or whatever, but that's not important right now. It really just says that the closer the clock is to the source of gravitation, the slower time seems to pass. Look at this circle. Orbits, planets, the sun, everything's all circly. Is it because of gravity? Gravity appears to act on the centers of objects. So everything tries and crushes itself as closely together as it can. And the closest shape tends to be a circle. The more mass something has, the more circly it seems. This also applies to orbits. Because of the way that gravity bends this little space-time thing, things tend to orbit in circles. Whenever explaining orbits or gravity or space-time, people often harken back to this classic example.
Well, instead of just letting go of one, what if I give it a sideways push? Now it orbits.
But wait a minute. Gravitational orbits are not circular, they're elliptical. So, can you explain me, if space-time bends things circularly, then why do orbits go elliptically? Well, I'm glad you asked that, my dear student. As I said before, this 2D representation is flawed, and space-time bends in 4 different dimensions. In a 4D representation, the bend is actually a hyperbolic system in a 3D representation. The reason an inertial object with momentum and energy would follow an elliptical orbit in this system is a bit too complex for me to explain to your monkey brain. So we'll just continue on because I don't want to do all this math. A good way to imagine a theoretical wormhole is to get yourself paper, pen, draw 2 points, and then fold the paper over so that the points are connecting. Congratulations, you've just created a space-time with a wormhole through it. Einstein's theory of general relativity kind of predicts the existence of wormholes. However, none have been discovered to date. A negative mass wormhole could be spotted by the way that it warps light that it releases. Hey, that sounds kind of like a black hole, which we have discovered. Now, young child, my research here does get a bit sketchy. There's a lot of conflating points, a lot of different theories, and I couldn't find one solid source of information. I'm not actually sure if wormholes are just black holes or not, but it seems that matter being able to escape from a wormhole is the biggest difference between wormholes and black holes. Now, there is one theory that if you mathematically take the inverse of a black hole, you get a white hole, in which matter cannot get into a white hole, it only escapes. You know, matter only goes into a black hole and never comes out. So where does that matter go? You could say white hole. Perhaps the black hole and the white hole are connected through space-time, and you get sucked into a black hole and spat out of a white hole. But some astronomers say that white holes could not exist because they would violate the second law of thermodynamics, which is why I believe that perhaps you get spat out into a different dimension in which white holes do exist. Extradimensional theory postulates that our universe is just a thin film of three-dimensional space, enclosed within a higher dimensional world in which the only force that can overcome the dimensional barriers is gravity. Put another way, the theory is that because gravity leads a large portion of its energy into other dimensions, we can only observe it in this dimension as a much weaker force than it actually is. This theory requires that the standard model is confined to a four-dimensional membrane, while gravity propagates in several additional spatial dimensions that are large compared to the Planck scale. Well, I've learned nothing, I've gained nothing. Now I've got to flee the country. Have a nice day, and make sure not to think too much. Graduation's coming up. I'm losing my sanity a little bit. And there's a car driving by me very slowly.